Part 4. The normal distribution. Look at the following frequency polygons / histograms. Okay, so remember the frequency polygon is the line that connects the midpoints, okay? And the histograms, of course, are the bars. So you can see, though, that the bars are fairly symmetrical, okay, in both cases. And, of course, there's a nice curve that goes through them. Okay, so the curves look a little different because they have different means and standard deviations, but they also do share some similarities. Okay? So, in this case, of course, I have a mean. This curve looks exactly the same as this curve, okay? But if you'll notice, their means are in different spots, okay? Whereas if you look at this curve, okay, it looks very different, but it has the mean in the exact same spot as this one. Okay, so we have all different kinds of curves, but how do we get them? Okay, so what do you notice about the approximate shape of the graph? It resembles I would say it resembles a bell. Okay, in reality, a lot of data follows this type of shape when it's graphed. Generally, measurements of living things such as mass, height, and length have this particular bell shape. Since it is so common in living things, mathematicians have given it a special name called a normal distribution. Every bell curve or normal distribution follows some basic rules or properties. Every normal distribution has a mean. We use the symbol x bar, as you may have remembered from last section, or we also use this funny looking U shape. It's actually called mu. It's another one of those Greek letters. Just like for standard deviation, we use the Greek letter sigma. The mean, the median, and the mode are all the same, or close to it, and are found at the line of symmetry. The graph is symmetrical about the mean, so that means there's 50% of the data on the left of the mean and 50% of the data on the right. Almost all data lie within 5 standard deviations of the mean, and the total area under the curve represents 100% of the data, or one entire unit. So you can take a look here at this nice little picture. Okay, the mean, the median, the mode should all be in the middle. Half the data is on the left, half's on the right, and all of it is 100% or 1 unit of area. Okay, the normal distribution follows the 68, 95, 99% rule. Okay, so about 68% of the data are within 1 standard deviation of the mean. So what that means is either left or right of the mean of 1 standard deviation. 95% of the data is within 2 standard deviations of the mean. Okay, that should all say all of the mean. And about 99.7 are within 3 standard deviations of the mean. Okay? All right. So if we were to draw this, the mean, of course, goes in the middle, and we call that mu. Then to the right would be my mean plus 1 standard deviation, mean plus 2 standard deviations, and mean plus 3 standard deviations. To the left would be the mean take away 1 standard deviation, mean minus 2 standard deviations, and mean minus 3 standard deviations. So if 68% are within 1, left or right, then remember these are symmetrical, so half would go here and half would go here. Well, half of 68 is 34, so that represents 34%. Okay, 95 takes into account, because again, we can't have more than 100, already takes into account that 68%. So what's left over? Well, if we go 95, take away 68, we would get 27. But remember, it has to be broken evenly onto each side of the mean, so therefore 27 divided by 2 is 13.5. Okay, great. Next, we have 99.7 in my 3 standard deviations. Again, that already includes the 95 and the 98 or the 68%. So when we subtract those, we get 4.7%. But again, that represents this and this, so we have to divide that by 2. Okay, so this is 2.35%, and so is this. All right, great. The last little bit represents 100%, take away 0.7%, which leaves us with 0.3%. And again, that's divided to both sides, so 0.3% divided by 2 equals 0.15%. So that goes in here. Okay, and in here. All right, so if we add up all these percentages, they should add up to 100. Okay, let's have some fun with this. Normal curves can vary in 2 ways. The mean determines the location of the center of the curve on the horizontal axis, and the standard deviation determines the width and height of the curve. Example 1. The data given represents the pulses of 30 20-2 students taken just before a math exam. Notice how high some of those are. Anyway, are the pulses normally distributed? Prove it mathematically. Okay. In order to prove it mathematically, we have to show that the mean, the median, and the mode are all relatively the same. Okay, so again, you can use your graphing calculator to help you figure out the mean and the median. Okay, so again, mean you could find by adding them all up, so taking the sum and dividing by 30. Okay, so, or your calculator will do it for you if you put it into your lists. So, for the mean, I got 73.3. Okay, the median, of course, is when you take all your numbers, add them up, and divide, or find the ones in the middle. Since there are 30 numbers, you want to find the numbers that are in a 15th and 16th spot, and then add them up and divide by 2. So the median is at 73.5. Well, that's looking pretty good. Those are awfully close together. Okay, the last thing we have to do then is show that the mode is pretty close to those. When I did this and organized them from smallest to largest, I found that 80 appears 4 times, but also so does 68. 1, there's 2, and 3, and 4. So the mode is both 68 and 80, neither of which are 73-ish. So therefore, the pulses are not normally distributed because the mean, median, and mode are different. Okay, they all have to be relatively the same. Explain how the measures of central tendency support your decision in Part A. Okay, so, okay, they would all have to be the same. Or very close to the same. Okay, good. So, that's it for that page. Boom, one more to go and then we'll be all done the notes. Okay, number 2. Example 2. A shipment of beach balls with a mean diameter of 28 centimeters and a standard deviation of 1.3 centimeters is normally distributed. What percent of the beach balls have the following diameters? So remember, percents are the values in between the standard deviations. Okay, so what you want to do is let's just draw ourselves a little bell curve here. Okay, when you've drawn as many bell curves as I have, you'll be just as good as this, as mine. Okay, in the middle goes our mean. Our mean is 28. And we'll draw in some standard deviations. Okay, so remember it's 120 or it's 28. To get to this bar is my mean plus 1 standard deviation. So 28 plus 1.3 makes 29.3. If we add 1.3 to that, we would get 30.6. And if we add 1.3 to that, we would get 31.9. Now we can do the same on the other side. Okay, so minus the standard deviation, 28 take away 1.3 would be 26.7. Take away 1.3 would be 25.4. And take away 1.3 would be 24.1. Okay, remember again that this is 34%, 13.5, 2.35, and 0.15. And of course the same thing is mirrored on the other side, because these are symmetrical. Okay, so the first thing I would do when I'm dealing with distributions is plug in those numbers. You are going to have to remember them. Okay, so between 26.7 and 29.3. So 26.7 is here, and 29.3 is here. So that would be 34 and 34. Which adds up to 68% of the beach balls are between diameters of 26.7 and 29.3. Smaller than 24 or 25.4, part B. So 25.4 is right here, and although my writing is really crappy, you can see that 2.35 and 0.15 are in there. So 2.35, whoops, try that again. 0.15 adds up to 2.50%. All right, and that's how many beach balls have a diameter that's smaller than 25.4 centimeters. Part C, greater than 31.9. So 31.9 is right here. So this is the value I'm looking at. It's simply read off the table, 0.15%. Okay, here's an example for you to try. Again, you can shut off the video, try it yourself, turn it back on to see how you did. You can follow along and write as I do, or you can listen to me do the example and then go back and try it yourself. Okay, example 1. The set of data of class marks has been ordered from least to greatest. Oh, how kind. And it's shown here below. So we got a bunch of numbers going from 2 to 15. Okay, calculate the mean, the median, and the mode, as well as the standard deviation. So again, that's where I would have you pick up your graphing calculator. Make sure you clear all lists. If you have an 84 version, you would go second plus sign, and that would clear all of your lists. Okay. If you have an Inspire, just start a new doc. Okay, good. Then again, just plunk all of your data in L1 or your first column. Okay, and then use your calculator to find the mean, the median, the mode. Of course, these are already ordered from least to greatest, so let's see which one has the most. It looks like 8 has 6 numbers, or 6 8s there, so I'm thinking the mode is going to be 8. Okay, and again, your calculator will help you find your standard deviation. Go ahead and pause the video to type all that in. Okay, when I did it, I found the mode to be 8.62. The median, or the number in the middle, is 8. And again, there's 29 pieces of data, so halfway in would be 15. Okay, so if you count 15 from each end, you should end up on an 8. Last, the calculator also told me that this standard deviation was 2.85. Now, I would like us to use this information, and again, we're going to make a frequency table. So note that on a bell curve, the interval is the standard deviation. So we're going to use this as our interval, okay? And again, what you should do is start at the mean and add and subtract that interval until you get all of your intervals. Remember, we're only allowed to have a minimum of 5 and a maximum of 12. So I think when this worked out, I did 6. Okay, so my class marks are going to range from 0.07 to 2.92, 2.92 to 5.77, 5.77 to 8.62, 8.62 our mean, minus 11.47, 11.47, sorry, not minus, but 2, 14.32, and 14.32 all the way up to 1717. Okay, when you start putting your numbers from up above in, we have one number between 0.07 and 2.92. That's the number 2. 2.92 to 5.77, that would be 4 and 5, so there's 2 numbers. 577 to 862, 1, 2, 3, 4, 5, 6, 7, and then all those 8s, okay? Add them up, you get 13. So 9 to 11, that's 3, 6, and 2 more make 8. 1147, so that's 12 and 13. There are 4 of them. And 1432 to 1717, there's only 1. Okay, so along the x-axis will be the class marks. And on the y-axis, of course, will be your frequency. Okay, frequency started at 0. I think there's enough for 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good, so every bar is worth 1. Here I'm going to start with 0.07, and I'm going to go over 2, and then I'm going to put my next first number. 1, 2, 5.77, 1, 2, 8.62, 1, 2, 11.47, and that one's going to be 1432. Okay, remember that you need to draw a histogram first to create a frequency polygon. So the first one is 1 unit up. Good, and again I like to color mine in. The next one is 2 units up. Okay, the next one goes all the way up to 13. Okay, and color that in. Okay, next one goes up to 8, 2, 4, 6, 8. Followed by 4, 2, 4. Good, followed by 1. Okay, 1, 2, 2, 1, 2, 3, 4, 5, 6. Okay, we're all here. Probably should put a title on this thing if it was for marks. Okay, so just call it a class marks frequency table. And in order to draw a frequency polygon, we need the midpoint of each of my bars. Just draw a dot at the top of each one in the middle. And then we're going to connect the dots. Okay, so what you want to do is, I'm going to change my color here for just a moment so you can see where my frequency polygon is. So start at the 0, and then again, nice straight lines, using a ruler preferably, and connecting your dots on your frequency polygon. Okay, good. Alrighty, so the question says, explain why the distribution is or is not approximately normal. Well, as you can see, the mean, the median, and the mode are different values. So therefore, and it's not got that nice, want that nice bell shape, okay, when you graph it. So it's close, but not exactly there. So I would say this is not normal. Like a lot of things I see as a teacher in my classroom, they're not normal, okay? And again, because mean, median, and mode are different. Okay, and again, we don't have that nice symmetry on our bell curve. Okay, with our frequency polygon. Great. Give this a nice try on page 279. Questions 1, 3, 4, 9, and 10 Show this formative assessment to your teacher when you are done.